In this module, you will learn about DBMS, Relational Database Model, Relation, Tuples, SQL, DDL, DML, Relational Algebra, Selection, Projection, Union, and Cartesian Product. Let's begin the session by understanding about database. Database is a collection of related information that is organized in a way that is easy to access, modify, and maintain data. You can obtain the contents of a database by combining data from all the different sources in an organization. You need Database Management System, DBMS, to manage the database. DBMSs are specially designed applications to create connection between user and program and to store data in an organized manner. DBMS allows you to create, modify, and administer the database. Examples of DBMS are MS Access, MySQL, PostgreSQL, SQLite, Microsoft SQL Server, Oracle, SAP, DBase, FoxPro, etc. The relational data model was formulated and proposed by Edgar F. Cord in the year 1969. It is a database model based on first-order predicate logic. The first-order predicate logic is a symbolized reasoning where the statement is broken down into a subject and a predicate. In the first-order logic, a predicate refers to a single subject only. It changes the properties of the subject. In the relational data model, database is a collection of related tables where each table is referred as relation and has its unique name. Tables are combination of rows and columns. A row or horizontal subset of a table forms a tuple or record, whereas column, the vertical subset of a table, represents an attribute. Next, let us learn about relation. In database, a relation refers to a table where data are organized in the form of rows and columns. For example, relation employees. Moving ahead to the next concept, domain. A domain is the original sets of atomic values used to model data. It is a set of acceptable values of a particular column, which is based on various properties and data types. For example, in previous relation employees, the domain of gender column has a set of 2 possible values, male or female. The domain of marital status has a set of 4 possible values, married, unmarried, widow, and divorced. Next is tuple. Tuple is the horizontal subset or information in a table. It is also known as a record that gives particular information of the relation table. For example, in employee table, one row gives information about one employee only. Moving on to the next concept, keys. Keys are very essential part of the structure of a table. They help in building relationship between tables by enforcing integrity. There are 4 main types of keys, namely candidate keys, primary keys, foreign keys, and alternate keys. Let us look at each of keys in detail. Primary key is a column or set of columns that uniquely identifies a row within a table. Candidate keys are set of fields, columns with unique values in the relation that can act as a primary key. A foreign key is a column or a combination of columns that is used to establish a link between two tables. Out of the candidate keys, keys that remain after selecting a key as primary key are known as alternate key. The degree is the number of attributes, columns, in a table, whereas cardinality is number of rows, tuples, in a table. Have a look at an example. Here, relation, employees, fields, attributes or columns, emp number, emp name, gender, marital status, and designation. Tuples, rows or records. Domain. Possible values of designation are general manager, front office, clerk, accountant. Degree 5. Number of columns. Cardinality 5. Number of rows. Candidate key. In the table, emp number and emp name has unique values. Therefore, emp number and emp name are candidate keys. Primary key. Out of the emp number and emp name, emp number is the primary key. Alternate key. In the candidate key, emp number is the primary key and the emp name is the alternate key. Now, let us learn about structured query language, SQL. SQL is a standard language used for accessing databases and allows you to create tables, manage data, and manipulate data. Using SQL statements, you can perform variety of tasks such as querying data, inserting, updating, and deleting rows in a table, creating, replacing, altering, and dropping objects, tables, controlling access to the database and its objects, tables, and guaranteeing database consistency and integrity. Having understood about SQL, let's list the advantages of using SQL. There are various advantages of using SQL, such as SQL is easy to learn and understand since it generally consists of English statements. SQL is widely used for relational databases. SQL is portable, so it can run in all servers such as mainframes, PCs, laptops, and even in mobile phones. SQL is used with any DBMS system with any vendor. SQL is used by all the vendors who develop DBMS. You can use SQL queries to retrieve large amounts of records from a database quickly and efficiently. SQL acts as both programming language and interactive language at the same time. SQL is client-server language, that is, SQL can be used for linking front-end computers and back-end databases. It provides client-server architecture such as email and the World Wide Web. SQL supports the latest object-based programming and is highly flexible. Based upon the purpose, the SQL statements are classified into 6 different categories like Data Definition Language, DDL statement, Data Manipulation Language, DML statement, Transaction Control Statement, Session Control Statement, System Control Statement, Embedded SQL Statement. Out of these 6, in this session, we will learn about DDL and DML. First, let us learn about Data Definition or Description Language (DDL) statements. DDL is a standard for commands that defines the different structures in a database. You can use these to create structure of a table, modify the existing structure of the table, and remove the existing table. Few examples of the DDL statements are create table, alter table, and drop table. Next is Data Manipulation Language, DML statements. DML statements are used to access and manipulate data in existing tables. You can use DML to insert data into tables, delete data from the table, retrieve data, and modify the existing data. Examples of DML statements are select, update, delete, and insert. Now that you have a good understanding on SQL statements, let us move ahead to learn about data types. The data type of a value associates a fixed set of properties with the value. Each value manipulated by SQL database has a data type. The three main data types in SQL are character, numeric, and date types. Let us understand each of these one by one. Let us start with character. Character data types store character data, which can be alphanumeric, words, or free-form text. Character data types are less restrictive than other data types and have lesser properties. Character data types are classified into three main types: char, varchar, and varchar2. Char stores fixed-length character strings. Space will be padded to string values before they are stored on the disk. When you use this type to store variable-length strings, it will waste a lot of disk space since it always allocates fixed memory. Format of char is char-n. It means fixed-length character string having maximum length n. Varchar is a variable character string. Varchar type can have maximum of 2000 characters. If you declare data type as varchar, then it will occupy space for null values. Format of varchar is varchar-n. That says variable length character string having maximum length n. Varchar2 is used to store variable length character strings. Varchar2 can store up to 4000 bytes of characters. Unlike varchar, in varchar2, the string value's length will be stored on disk with the value itself. The main difference between varchar and varchar2 is that varchar is ANSI standard but takes up space for variables, whereas the varchar2 is used only in Oracle but makes more efficient use of space. Format is varchar2 is varchar2n. Here are few examples. Char10 has fixed length right padded with spaces. For example, consider student name char10. Here, even if you store student name as Ram, the size of student name is always 10. That is, the first 3 places of the 10 characters is filled with RAM, and even the remaining 7 spaces are allocated to student name. Next, varchar10 has fixed length right padded with null. Consider student name varchar10. Suppose if you store the same value Ram in student name. In this case, first 3 places are filled with RAM and the remaining 7 spaces are filled with NULL, null. Finally, Where char2 10 has variable length. Consider student name where char2 10. Again, if student name is Ram, then only first three places are filled with Ram. On-screen table gives possible string data types used in different DBMS. Moving ahead to the next data type, numeric data type. Numeric data types are usually used to store number with or without fraction part. The numeric data types are of different types: number, decimal, numeric, int, and float. We shall look at each type in greater detail. First is number. The number data type stores fixed and floating point numbers. It is used to store integers, either negative, positive, floating, of up to 38 digits of precision. The numbers that can be stored in a number data type column are as follows. Positive numbers in the range shown on the screen with up to 38 significant digits. Negative numbers in the range shown on the screen with up to 38 significant digits, and 0. Format of number is number P, S, where P is the precision or the total number of significant decimal digits. Here, the most significant digit is the leftmost non-zero digit, and the least significant digit is the rightmost known digit. S is the scale or the number of digits from the decimal point to the least significant digit. Next numeric data types are decimal and numeric. These have fixed precision and scale. Format of decimal and numeric are as shown on the screen. Square brackets are optional, where P is the precision or the total number of significant decimal digits. Here, the most significant digit is the leftmost non-zero digit, and the least significant digit is the rightmost known digit. S is the scale or the number of digits from the decimal point to the least significant digit. Next data type is int or integer. The int data type is the integer data type in SQL. It stores whole integer number. Moving ahead to the next data type, float. The float data type stores real numbers. On-screen table gives possible numeric data types used in different DBMS. Moving ahead to the next data type, date. Date stores valid date values, which is ranging between as shown on the screen. Format of date is date. Now that you have good understanding about various data types, let us move ahead with next concept, relational algebra. An algebra is a combination of set of operands and a set of operators. You can form algebraic expressions by applying operators to operands. Relational algebra consists of a set of operations that take one or two relations as input and produces a new relation as output. Operators map values are taken from the domain and put it into other domain values. If domain is produced from more than one relation, then you get relational algebra. Various operations in relational algebra are selection, projection, union, and Cartesian product. Let us look at each of these one by one. First is selection. Selection in relational algebra returns those tuples, records, in a relation that fulfills a condition. This will produce table containing subset of rows. Syntax of selection is question mark, condition, relation. Example, the table E for employees, relation, employees. Here, if you have condition as shown on the screen, then the output of selection operation will be all the records having designation as clerk. Next is projection. Projection in relational algebra returns those columns in a relation that is given in the attribute list. Syntax of projection is by attribute list relation. For example, condition shown on the screen will display only two columns, emp number and emp name. Next is union. The union operator merges two or more tables. Each table within the union should have the same number of columns, same data types with columns in the same order. In the union operation, duplicate records are not included, the resultant table. Syntax of union is as displayed on your screen. Let us take an example to understand this concept better. Consider employees 1 and employees 2 as two tables. Query is shown on the screen. Resultant table looks like this. In the resultant table, employees 1 is copied as it is, but in employees 2, employee number E001, Sujata's information is same as employees 1. So this record will not be copied in the resultant table again. Employee number E002 is same as employees 1, but employee name is different. So this record is copied in the resultant table. Employee number E003 is not in employees 1 table, so this record is also copied in the resultant table. Last operation in relational algebra is Cartesian product. SQL joins relates information in different tables. It combines fields from two or more tables by comparing values of common columns or known as join condition. A join condition is nothing but a part of the SQL query that retrieves rows from two or more tables. If join condition is omitted or if it is invalid, then join operation will result in a Cartesian product. Cartesian product is a binary operation and is denoted by X. Cartesian product returns a number of rows equal to number of rows in the first table multiplied by number of rows in the second table. At the same time, number of columns equal to number of columns in the first table added by number of columns in the second table. Here is an example. Consider two tables, products and customers. Query is shown on the screen. Resultant table looks like this. Table 1, products. Number of rows, cardinality, is equal to 3. Number of columns, degree, is equal to 3. Table 2, customers. Number of rows, cardinality, is equal to 4. Number of columns, degree, is equal to 3. Cartesian product, number of rows, is equal to 3 into 4 is equal to 12. Number of columns, degree, is equal to 3 plus 3 is equal to 6. In this module, you have learnt Database is a collection of related information that is organized in a way that is easy to access, modify, and maintain data. Database Management System (DBMS) is a specially designed application used to manage databases. It creates connection between user and program and to store data in an organized manner. In database, a relation means a table, which is in form of rows and columns. A domain is the original sets of atomic values used to model data. Tuple is a row in a table. Attribute is a column in a table. Primary key is a column or set of columns that uniquely identifies a row within a table. Candidate keys are set of fields or columns with unique values in the relation that can act as a primary key. Out of the candidate keys, the keys left after selecting a key as primary key are called alternate keys. Data definition or description language (DDL) statement is a standard for commands that defines the different structures in a database. Data manipulation language (DML) statements are used to access and manipulate data in existing tables. Various string data types used in database are char, varchar, varchar2. Different numeric data type in database are number, numeric, int, float, decimal. Selection in relational algebra returns those tuples, records, in a relation that fulfill a condition. Projection in relational algebra returns those columns in a relation that is given in the attribute list. The union operator merges two or more tables. Each table within the union should have the same number of columns, same data types with columns in the same order. In the union operation, duplicate records are not included in the resultant table. Cartesian product returns a number of rows equal to number of rows in the first table multiplied by number of rows in the second table. At the same time, number of columns equal to number of columns in the first table added by number of columns in the second table.